Hi, welcome to introduction of this paper on clocking hidden repeating FRBs with unsupervised machine learning. I'm Oliver, a researcher from Taiwan National Tsinghua University. First, let's introduce the problem we are going to solve in this research. We know that FRBs can be classified as repeaters and non-repeaters. For repeaters, keep flashing, like this bulb. It is flashing and flashing, so we call it repeaters. Otherwise, we call it non-repeaters. It only flashes once, and it never happens again. As a result, we call it a non-repeater. Therefore, apparently, a FRB source seems to repeat is definitely a repeater. Like this, it is flashing and flashing and flashing, so it is definitely a repeater. However, an FRB not observed to repeat, it still potentially could be a repeater. What does it mean? Well, like this bulb, it flashed once, and it seems like it is a non-repeater because it never flashed twice. But if we observe it long enough, then we see it flash again like this. So now we know it is actually a repeater. But if we are not always looking at this bulb, then we will never sure it will flash twice. The point of this research is try to identify this kind of repeaters that's not yet observed to flash second time. Okay. Our approach to solve this problem is based on unsupervised machine learning. We utilize the FRB catalog provided by Chen FRB experiments. In each FRB in this catalog, we use 13 physical parameters. As a result, for each FRB burst event, we have 13 parameters here. And these 13 parameters form a 13-dimensional vector. As a result, this vector could be regarded as a point in a 13-dimensional space, a point in a high-dimensional space. Then we use an unsupervised machine learning model called UMAP model to project these high-dimensional points to a two-dimensional plane. We call it a low-dimensional projections. As a result, a point initially here might result in a point on a plane here. Eventually, our low-dimensional projection by machine learning result in an embedding plane look like this. The embedding plane results from the unsupervised machine learning model is the main result of our paper. In this embedding plane, you see three kinds of different FRB points. The gray points symbolize the non-repeating FRBs, which means currently we only see it flash once. The cyan points and the magenta points symbolize the repeating FRBs, which means we have already observed it flash more than once. The difference between the magenta points and the cyan points are the magenta points did not participate in the training process, but only used to validate the feasibility of the model. So the first point of this figure is you see the magenta point and the cyan point has similar distributions, which means the samples in the testing set and the sample in the training set has similar distribution, which states that this training result is feasible. And the second point we want to emphasize here is you see that almost all the repeating points, including the machina point and the scion points, are aggregating on the left-hand side, while the samples on the right-hand side are almost all gray points, which means they are all non-repeating FRBs. This is an interesting result that since we are using an unsupervised machine learning, so the machine actually do not have any prior knowledge about the FRB is repeating or non-repeating. So we can infer from here that between the repeating FRBs and non-repeating FRBs, there are actually a major difference on their physical features. As a result, our unsupervised machine learning model could classify it easily. So you see that the repeating FRBs are almost all on the left-hand side. Finally, the points we want to emphasize in this figure is you see quite a few gray points, which means the non-repeating FRBs are mixing with the repeating FRBs in the three clusters on the left-hand side, like this one, and this one. Okay. These facts coincide with our assumptions that the population of non-repeating FRBs has actually contaminated by the repeating FRBs. And these gray points here are very likely to be the actual repeating FRBs, but just their second birth haven't been observed by us yet. In order to interpret this embedding plan, we use a simple clustering algorithm to cluster it into 9 different clusters. For those clusters that has quite a few repeating FRBs, we call it repeater clusters. The 3 clusters are the red one here, the yellow one here, and the pink one below. The rest of the clusters, which almost do not have any repeating FRBs, are colored in another colors. Finally, we can identify the FRB repeater candidates. For those observed non-repeaters in the repeater clusters, we regard them as FRB repeater candidates, which are the blue points in these 3 clusters. So these blue points are the final goal of our research. We try to identify the hidden FRB repeaters, and these blue points are those targets we are trying to discover. Okay. And let's have our conclusion. We demonstrate in this paper that the unsupervised machine learning model can classify the hidden FRB repeaters even without any prior knowledge about an FRB is repeating or not. And second, we identified 188 FRB repeater candidates from the original 474 non-repeaters, which is a repeater fractions, roughly 40%. The original repeater fraction in the Chen FRB catalog is only 5%, which means our research demonstrates the repeater fractions 8 times higher than the original one. Finally, we have follow-up observations with fast telescope, and this observation is going to verify the result presented in this paper. That's all main points of this paper. Thank you very much.